Hello everybody. In the previous video, okay, we talked about the integral 0 to pi over 4 and then log of tangent theta. The theta is actually quite fascinating integral, okay, which is related to Catalan constant, okay, which is an infinite series, okay, start from k equals 0 to infinity, alternating, and the reciprocal of all the odd integers squared, okay. Now, we want to investigate the sine and the cosine version of this, okay? The log sine, okay, and the log of cosine theta here, okay? And in the video number 2, okay, we have tools, okay, which is very useful, okay? That is for the integration to 0 to pi over 2 and then function of cosine theta, okay? The theta, okay, can be converted into the same interval, okay? And the same function of, but argument changed to sine theta, okay? However, these tools or these tricks, okay, no longer be valid, okay, for the integral okay, involving different interval, okay. Here we see that the interval is 0 to power 4, and for these two guys, okay, is 0 to power 2, so which is different, okay, we cannot apply this on these two problems, okay. So we expected that these two integrals will be different, okay, so we name it I and J here, okay. Now, it is very easy to observe that I minus j is actually log sine minus log cosine, okay, so which is log tan, okay, which is this one, okay, so we write down, okay, this is log sine theta minus log of cosine theta, and then we know log subtraction of log is just division inside a log, okay, sine over cosine, which is tangent, okay, so basically this is just log tangent theta, okay. Power of 4 here, okay, sorry. And then this integral is already known, okay, we have already evaluated in previous video, okay. Number 3, okay, so we know the answer is minus g, okay, minus g. So we establish uh, a relationship between I and j, okay. Now the idea is that this is an equation involving two unknowns, okay, I and j, okay. If we could obtain another independent equation involving I and j, okay, we can just treat these two equations, okay, as a simultaneous equations in two unknowns. We can solve it, and then we can simultaneously got the answer for I and j, okay, immediately, okay. So how do we find another independent equations, okay? Okay, by simple trial and error, okay, basically. Here's I minus j. The best situation or best scenario, okay, will become I plus j, okay? So that we can add together and cancel each other. How about what is I plus j? Okay, we observe that this is just the log of the sine theta plus log of cosine theta, d theta. And then it will become log of sine theta times cosine theta, okay, d theta. Here, we minus that, okay? This is just a double angle formula without 2. So we add a 2 here, and then we subtract the log 2 here, okay? Because log subtraction just division, okay? The 2 will be cancelled out, okay? So we proceed here. Here, this will become log of sine 2 theta, d theta. And then here, log 2 is just a constant function relative to theta, okay? So we can get it out, okay? So we will become pi over 4 log of 2, okay? And then for this one, okay, it looks very similar, okay? Because the 2 theta here, okay? If this is theta, then that will be perfect, okay? So we use the u substitution, u equals to 2 theta, okay? Du will be 2 d theta. So d theta will be 1/2 of du, okay? So we put everything into this integral. When theta is 0, u will become 0. When theta is power 4, u will become power 2. Okay, here's log of sine u, and then the theta will become du, but we have to halve it. Okay, and then minus pi over 4 log 2. But this guy is already known, okay? We know that, okay? In video number 2, okay? We know that this is just minus pi over 2 log 2. Okay, this is the video number 2, okay? For those who don't know the procedure, okay? You can check out for the video number 2, okay? How to get this answer, okay? Anyway, we simplify the answer, okay? Here, minus a quarter of pi log 2, another quarter here. So we got pi, okay, over 2 log 2. So we got the I plus j is equal to minus pi over 2 log 2. Okay, instead of directly got the answer of I and j, okay, we got two equations here, okay? Now, the next step is very obvious, okay? We just have to solve these two equations, okay? So let me write down, okay? I minus j equals to minus t, okay? And then I plus j is equals to minus pi over 2 log 2, okay? So we add it together, we got 2i, okay? 2i will become minus g plus pi over 2 log 2, okay? So I will become minus 1/2 g plus minus pi over 2 log 2, okay? And then if we subtract this one from this one, okay? Okay, I don't know, oh, anyway, okay? J will become, okay, j will become 2j, so for of course, okay, 2j will become minus pi over 2 log 2 plus g, okay? So j will become minus pi over 4 log 2 plus g over 2. Of course, we can expand this, okay? So it will look a little bit consistent, okay? So we conclude that, to summarize, okay, we got 0 pi over 4, okay, log of cosine theta d theta, okay, which is j, which is pi over 4 log of 2 plus g over 2. And then for the for the sine, okay, sorry for the typo here, okay, the sine versions here, we will have this one, okay, pi over 4 log 2 minus t over 2, okay? So it is a little bit symmetrical, okay, about the minus pi over 4 log 2, okay? One is plus, one is minus, okay? So in this video, we show that we can evaluate these two interesting log sine and log cosine interval, okay? But with different interval, okay? From 0 to pi over 4, okay? Hope you guys will enjoy this video, and we'll see you in the next video, okay?